Upping the difficulty a little bit with question 3, here is a slightly unusual combining resistors question. Okay, so in this question we are combining identical resistors in parallel, and it says we've got n of them, so 1, 2, 3 and so on up to n, whatever that might be. So the resistors in parallel formula is, of course, that one. So 1 over the total resistance of the combination is 1 over the resistance of the first one plus 1 over resistance of the second one plus 1 over resistance of the third one, etc., etc., until you've done all of them. Okay, so looking at this, if I just had 2 resistors in parallel, then the right-hand side of my equation would be 2 over R. If I had 3 resistors in parallel, the right-hand side would be 3 over R. If I had 4 in parallel, it would be 4 over R, and so on. So that means if I've got n of them, the right-hand side is n over R. Flipping that gives us that the total resistance of our combination of n resistors is R over n. Okay, now, what they say in the question is that what happens to the total resistance of the combination as the number of resistors increases? The implication is that we're not changing the resistance of the resistors. So that R there is a constant. I normally put a K for a constant, but whatever you usually use is of course fine. So that means the total resistance of the combination is equal to a constant divided by n. And that, of course, means that the total resistance is directly proportional to 1 over n. And that's inverse proportionality. So this is the shape of graph that you would get, a curve, a downward sloping curve where the gradient is decreasing. Okay, we now look back at our answers and we've got, so A, R, N, so that, sorry, I used RT for R total, but Rn, the combination, decreases linearly. No, it's a curve. B, decreases non-linearly, yes, as N increases. So that's looking good. You can convince yourself that the other two are also wrong.